All right, I think we can get started. So hello, everyone. Thanks for joining the talk today. So before we get started, I wanted to remind everyone that the Zoom session today will be recorded. And if you are a registered participant, you will receive the link as well as the slides after the seminar today. And when you're entering the seminar room, you will be muted automatically. And our speaker today has mentioned that you are welcome to unmute yourself during the talk. And if you have a question to ask, or you can also type it in the chat window and I will monitor that for you. So without further ado, today we have Professor Guangqing Chi from he's a professor from Penn State. He's a professor in rural sociology, demography, and public health sciences. He's also the director of the Computational and Spatial Analysis Core. His expertise are in environmental demography, social environmental systems, population infrastructure dynamics, spatiotemporal modeling, and data-intense social sciences. So today he's going to talk about some interesting tools. So without me taking time, Guangqing, take away.
Okay,
Uh,
thank you, Prof. Hani, and thank you for the invitation. I will make sure that finish in time so that don't want you to meet this solo eclipse. Not sure about the weather in Hershey. Now we get rain. Not sure if we will be able to see it or not. Oh, okay, so yeah, let me share my screen here. Okay, you see my screen well?
Yes.
Okay. Okay, so I will talk about the health equity from two approaches. So one is, the original title is focused on the spatial big data analysis only, but I'm adding the community-driven approach for dealing with the health equity. As we know that the climate change now is really have lots of health impacts, and the impacts are even disproportional for minorities and other disadvantaged group. So first of all, what is health equity? What is health? What is equity? So if let's just think about any kind of this. Use one example. You just use the recent pandemic, COVID pandemic, as example to see the complexity of health equity. So you see, first of all, the pandemic. This is very complex. This is started from Wuhan, China, spread to the rest of the world, and there's the change over time as well. This involves the study probably any disciplines you would find a study to study this, although I don't know, astronomy maybe, I don't know I don't know whether they have articles on that, but basically just so many articles. And this all is also very dynamic and evolving. But okay, so just one example. But if we think about what is health, what health mean to you? Okay, so the health to me is not only like the physical health or mental health, but rather this is more broad about the human and community well-being. Okay, and the equity is not just focused on the racial ethnic groups, but also this can vary by gender, by some other minorities like indigenous communities, also by socioeconomic status. So we see some of the health issues are disproportional on the low-income groups. And also there's the spatial variation there. The impacts can be very different in rural versus urban, and also in developing countries. Okay, and then there are also special populations. Okay, so from my perspective, in order to tackle the health inequity, we need at least two things. One is the methodology. Okay, the advancement and adaptation of the research methods. And I will use my research to use 3 examples to illustrate why they are important. Actually, we already have lots of methods from like biostatistics, so spatial analysis, or even computer science. Sometimes I don't feel that from my perspective, we don't have to keep creating new methods. Rather, many of the things we could adapt them for the health research. And another thing important that I find is this community-driven approach. We want to do this transdisciplinary and also make this translational. because when we talk about health inequity, we are talking about communities or populations that are low income, minorities, that they, they may not trust scientists. When we want to collect data, they may not want to cooperate. So I will use some example to illustrate why this approach, why this transdisciplinary approach is not only helpful to do good research, but also to make meaningful research. Okay, so first of all, just a few examples about the methodology. The first thing is, if we think about nowadays, if we do research, this is a different, the landscape has changed so rapidly. Okay, when I was a graduate student less than 20 years ago, I just use one desktop computer with one data set, use one software, I can do analysis, write a paper. Nowadays, yeah, we probably still can do that, but you think about the opportunities provided by so many data we have, especially for those of us who do any kind of related to health research, it's not only about the health outcome, but also we talk about the contextual data. We talk about individual data like EMR data. We talk about behavioral data that we could put some app on your mobile phone or maybe on your iWatch to track you and see your the physical some of the measures that change. Also, there's the big social data nowadays. The social media is massive data. Okay, not only social media like Twitter, Facebook, but also there's the mobile phone data or even credit card data. And we could also web scraping data. There's so many data there. What if we could try to utilize all of them, just use them to the maximum? How we can do it, from my perspective, it's spatial analysis is a really good way to handle this when you want to integrate them together. How we integrate them. The spatial analysis allows us to overlay them together as long as there's any kind of geographic information. That's not how to be like give you the address of the patient data. We even if you can give a zip code, say which zip code this patient come from, or maybe the county level, we can, based on those geographic information, to integrate them together. Okay, the logic is making a sandwich. No matter how many layers of the data you have, just keep adding. Based on the geographic information, we can integrate them together. So the first thing is, first example here is the spatial regression models. So on the audience, I'm sure many of you are biostatisticians and statisticians. So there is this spatial statistics. This is sub-discipline. It has been there developed more than 20 years ago. And there are quite some textbooks out there. But for us, for social scientists, those methodologies, the equations are just too much. We don't really need to know how you prove the formula. What we care about is how to use it and how to be able to interpret it. So I work with Yun. She's a statistician from UW Medicine. And so we say, let's write a book. The book will be the formulas will be just enough. We don't want to put too many, or just sufficient to for social science. And so in this textbook, we started with the spatial thinking, why it matters, and then with the exploratory spatial data analysis, and then talk about the spatial dependence models dealing with spatial dependence and heterogeneity, and also multi-level modeling. And so here's one formula, just say one formula. This formula, for you guys this is a spatial temporal regression. Okay, so if we think about the COVID pandemic animation, you see the change over time and space, and we like to have a model say, what if we consider both in one model? And there are already formulas, models developed in your field. But again, it's just too complicated for us. So we say, why don't we make this a simple version and make this more like the regression, the typical regression that we are comfortable with. So in this model, we decompose the spatial temporal effects into 7 components. including explanatory variables, spatial lagged variables, temporal lagged variables, and spatial temporal lagged variables. And we also have our package, and so people could easily adapt that. Another set of the useful methods that I have been using in our research is the spatial array methods to identify the hotspots of population and environment interactions. Like, nowadays the wildfire, big issue, the flooding, also the earthquake. I'm not sure if you felt that earthquake last week. I was in Philly, the building was shaking. I thought there's a subway maybe that in the underground. Then they say it's an earthquake for the East Coast, which is very unusual. So, it's the methods here is basically, the logic is very simple. It's just like making that savage. You have a layer of the population you are interested, then you have a layer of the environmental factors, no matter erosion or earthquake, you overlay them together, identify the areas that have both where people you have and also have the environmental risks. Here's just one example, show you how to do it. So for example, in this index, well, we call population stress. But before that, we want to identify the areas with more population growth, but less availability of land for development. So we first develop a land developability index, based on the layers of undevelopable lands. So we treat those lands as undevelopable, then we overlay them together, and we can estimate the unit, estimate the availability of the land for development for each unit, no matter you want to do this at county level, zip code level, even block group level, because the data comes from remote sensing images, 30 meters by 30 meters. So you pretty much can aggregate it to any kind of the geographic level we want. And then we use the exploratory spatial data analysis method to overlay with the population growth rate to identify. So the red on the right side, the red refers to the counties where population growth is faster than the land loss. But the blue are areas that population grows slowly, slower than the land of the loss of the land. And also big data, nowadays, if it's the internet becomes dangerous or something, if you want to find something about somebody, you Google, you can find lots of information. There's the availability of the data, no matter the Facebook or Twitter data, and even credit card data. So there are some third-party company, let's just say credit card data. They would have the third-party company would make a contract or purchase the data from different credit card companies, and they can aggregate them to make, but also they identify, well, depends on which level of the privacy they want to protect. So we have access to a data called in-filter data, and that would give us the access to each individuals, give the name and the social security number over the past 30 years of information. Not much information there. Is for people, we would know their location. So if you, for the last 30 years, you never moved, okay, so you only have one point in the database. But if you move 10 times, so we have all the 10 points where you live, when you moved, and some more basic information about the house. So if you want to study like the migration research related, that or even mobility research, that give us the potential, not like existing public data like from census. We are not able to use the individual migration data. Also, mobile phone data is also the same thing. There are third-party companies purchase the mobile phone data from the mobile phones the service providers. So even if you don't make a call, cell phone company will still track us every 5 minutes, every 10 minutes, knows where we are. Okay, you think about it, that gives lots of data. Also, there's the points of interest, like if we just go to Google Map, you would find all kind of stuff, or zero data, or remote sensing data, land partial data. Nowadays, it's just huge, although they are very messy. That's the advantage is the data is massive and can be done, you can get the data in real time, but it's very messy. So for example, like for our traditional social research, we would use survey or maybe census data, but that is very slow, yeah, and very labor intensive and very expensive. If you think about like another thing another disadvantage of the traditional social data is there are many important population characteristics and behaviors that can't be measured by using some of the traditional survey methods. For example, let's say, try to find an example. Let's just say the earthquake. Okay, from last week, that's a very minor one. But if there is a, okay, let's just say that one. Let's suppose, well, maybe, I'm sorry, let's switch to a different example. Think about the wildfire in Hawaii last fall, that wildfire. That's a disaster. And if we want to study that, what we would do typically would be we write, if you write a grant, that takes a long time to write a grant, at least half a year, then you go through the review process, then get funding, at least 1 year. But there are also some kind of the rapid mechanism where you could say, contact the program officer, you see, I have this idea, I need to do this as soon as possible. But even that, it still takes time, 2 or 3 months already get into this. So when you go there to survey people, they ask things about how they feel about 3 months ago when the wildfire happened. The answer can be very different. Okay, versus if you get the information right during the wildfire. So on the opposite side of the big data is the potential is the data is huge, massive data. Because the N is large, that allows us to do a lot of stuff, lots of possibilities. That would allow us to study some of the hard-reached populations. Okay. And another big thing would be, especially for disaster, kind of climate hazards and disaster research, we want to have data in real time, okay, and want to be able to track people very quickly. So big data would give us that possibility. Traditional survey methods, no, that can't help us with that. So one example here is a recent project we get from NSF, the Arctic Soil Science Research. This is to study the food pantry access during pandemic. If we think about during pandemic, there are some of the food pantries. They help with people with low income, and we want to understand the impacts, how good they are. But the difficulty is, remember, during pandemic, we don't want to stay close, right? People don't really like to how you would do a survey. You do in-person survey, and even people, they would not necessarily go to the food pantry sites to get the food. Sometimes they could send the food to their house. So it's the traditional data collection methods is not going to work. And what we did is we get cell phone data. Okay, it's the cell phone data we get is called, oh, well, yeah, that black. I will get that when I get it. So the cell phone data. Oh yeah, yes, that's called there is called near data. There's also the safe graph data for the cell phone data. You can get that. So we say, okay, let's get their data, see if we could use their cell phone data to estimate population access, people access to the food pantry. The data is available for us. It's first of all, there are 2 sets of data. One is based on the place of interest. Okay, they will have the visitation. So for each food pantry, if you bring a cell phone, if you go there, it will record you. So you would that data will tell us like every 15 minutes how many people visited that particular food pantry. And another set of data is population flow from a block group to block group. Because we are moving, so okay, it will tell us the reason they don't give the exact location is because the protect the privacy. So you would have the flow from the millions of a block group to millions of block group. And so for that, we based on that, we validate the data, or how good the cell phone data represent the population, and link that to social economics. We also identify the food insecurity hotspots where the needs are the most. And at that time, there is also this mobile food pantry. Okay, try to set up some of the mobile food pantry to maximize their impact. So this our model could better help them to identify what is the best spot to do it. Another is the Twitter data. Okay, we have used Twitter data for many research. So this including the public perception of pandemic, climate change, the Black Lives Matters, and clean energy. We also, because of the Twitter data, we would, well, first of all, the Twitter data, not everybody use Twitter data. And then among those who use Twitter, only a very small percentage of them will turn on their location. So you would, the Twitter data would be able to track that. But even for a very small percentage, it's still a huge amount of data. Okay. And for us, I'm in sociology and demography. So for us, representation is very important. When we want to publish a paper, they will say, well, is your data representative? Well, Twitter data is not. We know it's not. Young people now, probably not that young. Back 10 years ago, young people use it more. Now they go to Instagram or something else. But urban people probably use this more. So we want to evaluate how bad it is misrepresentative. And then we say, what if we make the Twitter data to be representative? If we think about big national survey, those data are sample. They are smaller sample, much smaller sample than Twitter data. But they can still generalize this to the population. The way they do it is assign weight to each respondent. Okay, say this person represent this one person represent 50 female Black at the age 20 to 24, things like that. Okay, then you apply the weight to generalize the population. So we say, what if we can also do this to the Twitter data? We assign weight to each Twitter users and make it easy to be generalizable. So that's what our work is about. I probably need to move faster here. So very quickly. So here is the misrepresentation. You see here, the orange ones are overrepresented. Those are more is the metropolitan areas. Okay, and then the blues are underrepresented. Those are very rural, remote places. We also look at the distribution of the representation. So this is by age group. Okay, different age group, and for each of the 6 block, there are 2 graphs. The left one is metro, the right one is non-metro. And then within each of them, we have 3 categories. Middle one is well represented, left one is underrepresented, and then the right one is overrepresented. So we would see that for the first 2 age group, 20 to 24 and 25 to 34, they are way overrepresented, no matter for metro or non-metro areas. But as the age increase, you see for age group 35 to 44 becomes underrepresented. This age group we already underrepresented. But then as the age increase, this becomes even more underrepresented. Like the age group 65 plus, we don't even see any bars, very small bars for that well represented and overrepresented. And we are doing right now we are still testing our weight. We develop some weight to test whether we can make this generalizable and test the temporal drift and backward drifts. Okay, so okay, okay, so that's I talk about 3 things that I have been doing in my research, but there are also other challenges that could really benefit from your biostatisticians expertise. So one is the the data compliance and access. So nowadays, to get the data is not the issue. The issue is we want to get the data from many places, so that can involve the privacy issue, can involve the IRB data compliance. Sometimes just so hard to get the data from a different institute. Even think about I'm at UP, even if I want to get the data from your Hersey Medical School, sometimes it's difficult. So, as researchers, we may not necessarily be interested in each individual record. What we want interested is to get the data, to run the data and get the results. Okay. So what if we create something like the science gateway? Is we let we have a web-based interface, let the computer access and analyze the data behind the scene. So for research, for us, we can't see the data. We only see the results. What about that? Okay, the second challenge is the small data. Especially if we talk about the health inequity, think about the minorities, think about indigenous communities, sometimes it's really hard to reach, not only because maybe they live far away, very remote, or because they don't want to answer questions. If you say you want to study undocumented immigrants, you want to study say the mushroom farmers, okay, working in Pennsylvania. And first of all, they are located, you don't know where they are. I mean, they are in some of the mushroom farms, but they may not want to answer your question. They're concerned about what if you disclose, somehow they are concerned that you would disclose their identity, although researchers will protect that to the place, that would be a problem. Also, sometimes because of that, the sample size can be very small. For us, we like to use regression, but maybe we could benefit from like your clinical trial design, make a small sample size can still be able to make that useful. The third, we also do lots of qualitative research. Okay, and if you say you do a interview for 30 interviews, probably that's okay just to manually code that. But some of the research, like in one of my project in Kazakhstan, we did over 100 interviews. If we still use the traditional way to manually code, that's going to take lots of time. So maybe we could develop some kind of a deep learning method to code them, analyze them. Okay, so that's the first part. Okay, the first part is about the methodology. The point I want to make is many of the methodology, most of them probably is already there. I mean, for you guys, you may be interested or more motivated to develop new methods, but actually there are already so many very useful. If you could make this easier for us to use, or make this more accessible, that's going to help to study lots of the health problems. Okay. The second part of my talk here is I want to talk about the importance for using a transdisciplinary and translational approach. Basically, this is a community-driven approach for studying health inequity. I want to argue that this is necessary. Okay? And I'm going to make my point based on a new research program that I launched a few years ago. This is Arctic soil science research. The first project we get is called Polaris, funded by NSF. So why we study Arctic? First of all, the climate change is more severe than in the lower states. Their temperature rise 4 times faster than in the lower states. Okay, and what are some of the hardest hit places are rural, coastal, and predominantly indigenous. So this is very, an inequality from that perspective. This is a population that affects greatly. So if we think about the climate change, there's some climate change. We see that also in the lower states. For example, like wildfire, like flooding, like sea level rise, they have that. But they also have something very unique, like permafrost degradation. Think about their soil all frozen, their infrastructure, no matter the house or pipeline, they are all built on the frozen soil. Now they start to get soft. That's going to damage the infrastructure. Also sea ice that is a buffer to protect the shoreline. So with the temperature rise, the sea ice diminish. And so sea ice is not, it's not something that only for the polar bear. It's also for the infrastructure in the villages. And also they have extreme heat and cold. Well, extreme cold, we understand that, but they also get extreme heat. And if you go to Anchorage, the largest city of Alaska in summer, don't be surprised if it's hotter than Pennsylvania. And so we want to study how those climate change factors affect the social community dynamics in the middle, also ecology and infrastructure. And because most of our team members are social scientists, so we focus more on the middle part. We particularly focus on the food security and migration. And we also consider economy, policy, household dynamics, government, community governance, and the local and indigenous communities. Okay, so we see how they interact with each other. So when we think about how we write the proposal, okay, we do research. We have a lot. Everybody's so busy. We have lots of work to do. The practical way that we write a proposal, this is not a secret, is we write a proposal, get the funding, and go to the community to build a relationship and start to collect data. Okay, that probably works in many of the lower states, the typical community, but in indigenous communities, it's not going to work. So they want to be an authentic collaborator. What we think are risks for them, they may not agree. They would think of something else to be what they are concerned the most. And so this happens with these flowers. Flowers is our first project. We took that old approach. When we get to the field, they say, well, no, what you are interested in is not what we are concerned with. So it's extremely important to work collaboratively with them from the very beginning, from the proposal development stage, and to the data analysis and the dissemination of the results. Okay. Another thing is in indigenous communities, there is not a secret that there's a strong resistance to the outside world. And there's there's reasons for that. Researchers just quite often, just go to the field, collect the data, and leave. Don't really leave anything meaningful, useful to the community. That's not good for the community. So it's very important. And without the trust, and for some of the communities, without building that trust, they will not let us collect data. And it's not just our own IRB. We also need their IRB. Okay. Well, by the way, so from the first project, we learned the lesson, and we started with that project. So this is some of our team members from the first grant, and then we changed our approach, and we received 7 or 8 grants over the past 4 years. And now we have lots of collaborators, both with the university, state agency, as well as with the local communities. So the objective for our projects overall are, one is scientific objective is to understand how the interconnected environmental stressors and infrastructure disruptions affect the coastal Alaska communities. But the second goal is really, we say, not just to produce knowledge, but also, can we use what we learned to identify the important assets to help the local communities to adapt and become more resilient to climate-related change? Okay. So that makes it more beneficial to them. So the climate change really have lots of issues for Alaska. One is the food security. Okay. 92% of the food in Alaska, they are imported. And they traditionally rely on the subsistence lifestyle, they hunt. So on average, each person each year harvest 275 pounds of wild food. But even that, they still need 92% of the food, just on average. Climate change has huge impacts on the food distribution and production. So salmon, this is salmon, a big thing. So one of the study community is we call that is Bristol Bay region. That's the largest salmon run sites in the world, located in the southwest of Alaska. In the past 5 years, the production keep breaking the records. Every year break a record. But just north of it is called Guangqing Delta. Their salmon production dropped dramatically. So the federal government organized some kind of the help program to ship salmon from Bristol Bay to Guangqing Delta. And even the preserve of the salmon, you don't eat all of them at once. So you would preserve them for winter, for the next spring. And if the weather is not good, sometimes the meat will go bad. Okay. Also, land animals, they hunt, but this is so in the Bristol Bay, they used to have lots of caribou, but now they barely can see the caribou because they migrate north. Berry, yeah, they have all kind of berries. Blueberry, that probably is called a salmon berry. They also have watermelon berry. Watermelon berry is just like a watermelon, not that sweet, but just water. So it's the climate change because of you see now the climate change is not just say about temperature rise. It's really the variation. Okay, we have the variation. That's a big thing. So the weather is not happen not happen quite unusually lately. It's the spring come early, or there's a season that is supposed to have a sunshine all the time now become rainy. So this would affect their berry production and harvest. Then how about very north, like this is called the North Slope, the northern part of Alaska. They do whaling. Okay, so the village, they would hunt whale for food. And the way they preserve this is to dig a big hole, a pit, and they put the meat there that will sustain them for the next spring. But now it becomes, because of the soil becomes soft, the permafrost erosion. So sometimes these can get flooded. Water comes in. Then that will contaminate the food. That's going to be a big loss. Yeah, so the lower right corner of that picture is the whale meat. We were in a community called Rainright. They hunt whale, and they got a whale, so they opened the door, say everybody, including our visitors, can go there to take a piece, to take some piece. So yeah, and the food were expensive. You see here, milk. The first gallon is $8. Any additional would be $10. And Coca-Cola soft drink sells really well. You see for that 35 can costs $25. It sells very well. Sometimes they say they use helicopter to shape Coca-Cola because it makes very good money. So we studied food security and nutrition. Another example here, a picture here. You see the water, just 1 gallon of water in the grocery store at $10. So here we want to study how climate change affects the food security and nutrition through the changes in the availability, accessibility, convenience, and preference. We also compare the climate factors and the social changes, how they affect the food availability and the dietary choice. We know the traditional food probably is more healthy, and the grocery store food are less healthy and more expensive. But people, they like to buy grocery, the healthy food. Also, we link that to the migration, the culture, and also transportation. Here's another example. So this is another example. We work with the local community. So this is when we had the first trip, the first scoping trip. That was in February, the end of February 2020. And then when we come back, the pandemic broke out. And so the community we visited, they have a big concern about the COVID because the Dillingham, the largest salmon run sites, every year it's the end of May to early June. It's about 20 days. That's their fishing season. And that's where they get their mean income. So at the beginning of the pandemic, people really concerned. You remember we were concerned at that time. Not sure how serious this is. So they that divide the community badly. So some of the community members say we have to keep the fishing season open, because if we don't, we lose the entire year money. Another half or maybe more than half say, well, the health is a big issue. We don't want to risk the life. And the reason they get more concerned is they have a huge amount of immigrants during the fishing season. Okay, so they have about 2,200 people, local residents. But during the fishing season, 3 times of migrating workers come from all over the Lord states and other countries. Okay, so we work with the community, write an NSF grant, where quickly we get the money and we do surveys, see how people pursue this. So here, the story here is this graph. If we ask how concerned they are with the pandemic, so we have 2 groups. One is the residents, another is non-residents. Those are the seasonal workers. So on the right side, the residents, you see we further separate them into 2 groups, the low income and the high income. So for the residents, it is the Alaska natives who are low income. They are the most concerned about the pandemic. Okay, others for the high income, there's not that big difference. Then for seasonal workers, it is the low income Hispanics are concerned the most. And here we ask, whether they could find another job if they don't participate in the fishing season. So for the right side, for those say they think they can find other job opportunities, the variation the difference isn't that big. But for those say they can't find other job, and for those who are in the low income group, the most left column, we see that the Hispanic and Alaska natives, they are more likely to participate in the fishing. So the story is that the minorities and the low income groups, they are the most concerned with health issues, but it is the same group of people who have to work. Okay. Yeah, this is a mobile phone data. Sorry, I talked about that already. Yeah, I think I've run out of time here. Well, maybe just one last example here. Okay, just one last example. So this is again in Dillingham, and we want our project to be useful to them. So we talk with them. They say, okay, one thing they need help with is, you see on the map there is this red within this red line. That's their wastewater treatment facility. It's next to the ocean. They keep losing land. They are concerned one day it will come to the wastewater facility. So we use satellite images, and also we set up our own monitoring sites to measure the change. And we found that it loses about 15 feet of land every year. That will take only 16 years to reach to the wastewater facility. And that, which is not much time, 16 years, to make any kind of the construction, it takes lots of time. So with our map, with our projection, they applied for federal funding, received over $10 million to identify a new site, and already in the planning moving stage. Okay, I think I'm going to skip that one. Then, well, by the way, that's Obama, President Obama dance their traditional dance when he visited there. And then when we were there, the same lady teach us that dance. Yeah, so my point here is, one is to tackle health inequity. One is needed to be creative, to modify your methods. the other is community-driven approach is essential. With that, I stop here. Any questions? Thank you for your patience.
Thank you, Guangqing. So if the audience have questions, you should feel free to unmute yourself and ask, which I think is the easiest, but you can also type it in and I can ask the question for you. Yeah, Kelly, go ahead.
Thank you so much for your presentation. So I just had a quick question, and I may have totally missed it. I know you said usually it takes a little while for the grant process to, it takes a little too long for the grant process to go on to be able to, when you're trying to leverage these big data approaches. But I'm curious about what the IRB process looks like, and if you've ever run into any issues, especially when you're using something like cell phone data or Twitter data.
Yeah, this will be case by case, depends on, the how much private information the data disclosed and what research question, to what level the data you want to use. So it's case by case. If okay, maybe we'll start with one example is the credit card data. The credit card data mentioned in filter that the data they have will give us the access to individual level. We'll give you the name, give you the address, give you the social security number, which is so detailed data. For that data, there are two levels of IRB, and it depends on whether you want to see their name and social security number. So the data are presented in two levels. Depends on which research question, to what level the data we want to use, we would apply for different level of the restrictions. So IRB approach, well, I guess that will, if you're talking about the timeline, especially for the research that needed to be rapid, you need to do as soon as possible. One way, well, that submit a proposal. One is that if we already have IRB approved, that would be great. So you would put that IRB approval into the proposal submission. But most often in my experience is we don't have IRB ready. So we submit the proposal, but indicating that the IRB is pending. Once the funding agency say they intend to give you the award, they will tell you, in the email, they say, okay, I intend to fund you the project, but here are a few more things I need from you. One of them would include IRB. The IRB would, at that time, you need to get IRB approval. Okay, but there are two approaches. One is, if you already have your questionnaire designed, have your protocol developed, you want to go through the thorough IRB approval, you can do that. But if you say, I don't have time, but I really want to get the money in as soon as possible, the IRB typically can provide like an exception, not an exception, something it's rapid. It will indicate that
The expedited review.
yes, it's expedited, but they will give you approval saying that you can use this paperwork to get the money in. And while you are doing your research, before you go to the field to collect data, you still need to do that, the full IRB review. So it's case by case. And yeah, any further question on that?
No, I appreciate it, and it's definitely something that I may reach out to you more about. But I was just curious if that's posed any issues. But it sounds like at least Penn State IRB is pretty receptive to working with some of these big data, especially when you can specify at what level the identifiability, I guess, of respondents would be. Thank you.
Yeah. Yes.
Do we have any other questions?
Well, I have my email. My email gchi@psu.edu. If you have questions or you want to meet separately, I'm a director of the computational spatial analysis core. We provide data analysis, so collection, service. So if you are interested, I will also be happy to talk about that part.
Yeah, and the registered participants will receive the recorded link to this video as well as the slides. Just in case if you don't have the email, I can also type it in here.
Yeah. Okay. Yeah. It's in the chat.
All right. Well, thank you very much, Guangqing. I hope oh, you have a question?
Me?
Okay.
Oh,
Saying
Casey.
hi.
Oh, hey, Casey.
Yeah. All right. Well, thank you very much. And we have our next talk on April 22nd, and I hope to see some of you there. Thank you very much.
Yeah, thank you. Enjoy. Be careful with watching the sun.
Yeah, exactly.
Okay. Okay, bye.